Okay, this is section 7.4 for AP Calc 2, trig substitution. This is not to be confused with section 7.3, trig integrals, which was a nice tame section. This is not a tame section. This is a legitimate tough section. So I'm going to try to break it down and make it as easy as possible. The type of integrals we're talking about here have square roots of u squared minus a squared, or a squared minus u squared, or u squared plus a squared. They just look like this one does. We have an x squared minus 4. The reason we need a new technique is nothing else will work. This doesn't fit like arcsecant or arctangent or any of those. If I had an x on top, I could make it a UDU problem, but I don't have an x on top. So we just need another way to deal with ones like this. So let's just have a little background first. You don't need to write this down. We're going to just talk for a second about substitutions. Okay. There are a lot of detailed steps in this one, but I just want you to realize that the substitution that you choose is chosen because it works. You can decide to set up, whatever substitution you want. And I'll show you with just a basic example. Okay, we're starting out here in X land, or X reality. It's like the Matrix. You don't know really what world is real, but you know you're in X world to start out. This equation is easy. You could subtract the 4, divide by 2, and we know that X is 3 right away, because X being 3 gives me a true statement. But let's just create a little passageway. It's going to be the portal from X world to Y world. And I'm going to sub out my x and put in a 3y. Okay, I set this rule up. I made it up because I wanted to. There's no book that says I have to use x minus 3y as the portal from X reality to Y reality. I just did it because I wanted to. And the reason you're going to do it in your integral is because it's going to work. But you can sub anything out that you want. Just use the same doorway to get back to the reality you want to be in. So let's just make this substitution, try to make sense out of this. I can take out my x and put in a 3y because I said that that was okay. When you write your portal and you make up your rule or your doorway, it's legit. You can use it. It's just when you go back, you have to use the same one. So let's figure out what y is. 6y plus 4 is 10. Then subtract 4 and you get 6y is 6 and y is 1. Okay, so that's really great, but I don't really care what y is. I want to know what x is. That's the original question. Figure out what x makes the equation true. Okay, so lucky for me, I've got a way to get back from y reality to x reality, and that is the doorway portal that I made up earlier, which is x equals 3y. Okay, if x is 3y, then x is 3 times 1, and x is 3. Okay, so good for us. I made a really easy problem, really difficult, by swapping out of x reality into y using this doorway, and then back into x reality. All right, the point is, you can create a doorway to be whatever you want. You set up the rules for your portal. Just make sure that you use it going backwards as well. Okay, so let me start over with this integral that's our original question. I'll just move it down. How about that? Okay, so here's the original question. And remember, we're going to set this substitution up because it's going to work. And much wiser people who've come before me have given us hints on what doorway to set up if we've got certain setups. In this case, we have x squared minus 4, and there are rules that we'll eventually get to that tell us which one of these portals we need to set up. Okay, so the one I want to create here is a substitution based on a triangle. Okay? So, and like I said, you will learn that this triangle is associated with integrals that have u squared minus a squared in them. But for now, I'm just gonna give it to you, and you can just trust that this is the one you use. So let me just set up a little triangle. I'm going to put my square root over here on one of the legs of the triangle. Okay, if that's the case, then my A would be the other leg, and my U would be the hypotenuse. Okay, so just a quick Pythagorean theorem you can check to see that this is true. If I take my two legs, 2 squared plus square root of x squared minus 4 squared equals x. That's true because 4 plus x squared minus 4, should equal, should equal x squared. There we go. So that works. And this right here is my portal. Okay? You set up the rules, so I want it to be that way, so that's the way it is. Now I'm going to substitute out of x land, but I'm not going into y land like I did on my basic example. I'm going into theta land. Okay, so once I leave x land and get into theta land, I'm going to have an integral that I can work with, and then I'll just substitute back into x land using this doorway backwards. All right, so once your doorway is set up, you want to just list some information that you get from this triangle. Okay, from my doorway above, if x is 3y, then I just made that up, and it's just true because I said so. So since this triangle is true because I said so, I'm going to use it to get rid of all of the things in my original integral. I need to know what that square root equals. I need to know what dx equals. And I need to know what all those are in theta world. So first of all, let's agree that x equals 2 secant of theta. Okay, that again is a pattern that you will use with this particular portal, but just for now, let's just agree that it's true based on the triangle. Okay, that's based on the fact that if we look at secant, which is the inverse of cosine, you know cosine is adjacent over hypotenuse, so secant must be hypotenuse over adjacent. And if my angle's theta, the hypotenuse is x and the adjacent is 2. So secant theta would be x over 2. And then if you multiply both sides of that equation by 2, you get x equals 2 secant theta. Okay, so I'm going to take all that out. That's kind of the background, but that's why x equals 2 secant of theta. Why is it true? Because you make the rules, and if your triangle, if that's a triangle you want to use, then this is a true statement based on the relationship between x and theta. Okay, so once you choose x, figure out what dx is. The derivative of 2 secant theta is 2 secant theta tan theta d theta. All right, how do I know that's true? Well, because I knew what x was. How did I know what x was? Because I made up the rules for what x was. Okay, and my other leg of my triangle, the square root of x squared minus 4, is equal to 2 tangent theta. All right, for a similar reason. The tangent of theta would be opposite over adjacent. And my opposite of theta is the square root, and my adjacent is 2. Multiply both sides of that by 2, and you get that the square root is equal to 2 tan theta. So what you're doing here is coming up with a list of items that you can use to transform out of x land into theta land. All right, so my original equation was the integral of 1 over this particular square root dx. So I've got now the ability to swap some of these things out. I'm going to take this x squared minus 4 square root, which I know is equal to 2 tan theta. And I'm going to take my dx, which I know is equal to 2 secant theta tangent theta d theta. And at this point in the process, I have changed realities from x to theta. Okay? The reason I did is because this new integral that I'm working with is something I can solve, and the original one that I started with I could not solve. All right, so now I just need to solve this integral with the trig functions in it, see what I get, and then go back to x world. Okay, so this integral has, let me clean it up a little bit. I've got a 2 on the top and the bottom, which will cancel each other out. I've got a secant tangent and a tangent d theta, and since I have the tangent on both, this integral simplifies all the way down to what's the integral of secant of theta d theta. Okay, and this is one of the formulas right from the front of your book. That's equal to, don't need that anymore. This is equal to the natural log of the secant of theta plus the tangent of theta and absolute values plus c. All right, so this is the integral, but this is the integral in theta land. If you remember our opening example, this is what would be like y equals 1. Y equals 1, and that's true, and that's great, but I don't care what y is. I care what x is. So I need to use my portal, this triangle, and the relationships in this triangle between x and theta, and go backwards to figure out what is my answer in terms of x. Okay? So basically that's going to involve figuring out what's the secant of theta and what's the tangent of theta. Sometimes you will already have addressed those two things, and sometimes you won't. But one way or the other, you have to come up with an expression for what is the secant of theta. So let's look back and see if we have any relationship between the secant of theta and x. Okay? If you look back here, if x is 2 secant of theta, then I think we would all agree that secant of theta is equal to x over 2. So this is the substitution that I want to use coming back. Any of these relationships between the thetas and the x's can be used on your trip back through the portal. So secant of theta equals x over 2. So I'm going to take out secant of theta and put in x over 2. All right, my first step in changing from theta reality back to x reality. We have the natural log of, my first part turns back into an x over 2. My second goal is to figure out what is tangent equal. Well, let's look back up and see if I have any expressions for tangent. Well, I have close. I have right here that 2 times the tangent is the square root, the original square root that I started with. So I think you would agree that tangent is my original square root over 2. Okay, so plus tangent is plus my original square root that I've been dealing with the whole time, x squared minus 4 over 2 plus c. Okay, and to be technical, this c and this c are not the same, so I'm going to put a c1 there. That really is just a small technicality. So this is my final answer. This is my answer in x reality. I've integrated it. I had to go into another world for a few minutes to be able to, but then I switched back out, and I'm good. My answer key cleans up this answer a little bit. So just for fun, we'll do that. I have a 2 on the bottom of both. So I could write this as 1 fraction x plus the square root of x squared minus 4 over 2 plus c. And then if you remember your log rules, this would be the natural log of the absolute value of x plus the square root minus the natural log of 2, because log of a over b is log a minus log b plus c. And because log of 2 is a constant, you can just kind of roll all of this into one big fancy constant. It should have another name again, but it's all right. I'm not offended by calling it the same C over and over again. I should probably call this one C2, and then when I wrap C2 together with log of 2, I get another one C3, but that's okay. They're all arbitrary anyway. So final answer for that long process is this natural log. All right, so just a quick recall of that whole thing. I've got an integral that I can't deal with right here. 1 over this square root. I set up this triangle because that's the rules that are listed in my book. When I have that square root, I use that triangle. So we'll work on memorizing those. But for now, just realize that this triangle is the doorway between worlds. That triangle gives me all of these relationships between x and theta. Okay, you need a relationship in your doorway. Remember, my relationship on this opening problem was x equals 3y. That relates x and 3y and lets me change between worlds. So I do that here, except I'm using theta and x. And I substitute out all parts of my original, including dx, and I put those all in terms of theta. Dx usually is kind of forgotten in regular integrals, but in this particular setup, dx becomes a big part of your question. So don't forget your dx, and then just integrate the trig that you get. Sometimes that's easier than other times. Once you integrate the trig, go back into x world and then clean it up if you can. Okay? So that's just the first one. It might be a little overwhelming, but you'll get used to it, and we'll spend a couple days on this topic. All right, so I'll see you in class. Young is out.